All right, students, I wanted to do a quick talk about the difference between the mean and the median, and maybe the mode as well while we're at it, and do a little demonstration here of those values. As we know, if we picture this Lego creation as a histogram, and so over here in this bin, I've got one value, and in the next bin over, I've got 1, 2, 3, 4, 5 values here. And then the next value over, I got 4 values, and then 2 values, and so on across the look. I can look at this as a histogram that we've constructed. Each classification depends on the number of bricks that you have in that sort of classification that you've got there. If we look at what the median is, if you count up all the bricks, I believe this blue one right here is the median brick. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bricks on this side of the blue one, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bricks on this side of that blue one. So that blue one represents the median value. Half the values are one side, the other half of the values are on the other side. This distribution is strongly skewed as well because of that. It's very not symmetrical. Of course, the mode would be the tallest stack here that I've got the most values in this one, this bin, so that's going to be our mode, our median, our mode. And then the mean is the balance point. It's the point where your distribution balances. And let's see if I can get it to balance here. It's right about where, there we go. I guess that black one's a little bit off. I'll just shift it over a little bit there. Right about where that black one is our balance point. That's where our distribution balances, there on that black one. And so that would be our mean. So the mean is your balance point, sort of thing. So the mean is highly influenced by outliers. If I were to take one of these bricks and move it farther over out there, that's going to shift the balance point over. I'm going to have to slide my finger over to get it to balance. I can't really slide it much farther over because I've run out of Lego space. But I think you get the idea there that the farther over that one is, it's going to adjust the mean. It's going to shift the balance point. It won't change the median. There's still going to be, the same number, 12 bricks on this side of that blue brick. But if I move this one farther over, it's going to shift the balance point. It's going to shift the mean over a little bit there. And you can kind of, I hope you've kind of got some experience with that. If you hold a pin, if you're trying to get that pin to wiggle, if you press in really close to where you're holding it, it's not going to do much. But if you apply a little pressure way over here, it's going to really make you can twist it easily, and sort of to compensate you have to slide your other finger over, but you've got a lot more torque, is what they call it in physics, is torque, or in engineering they'll call it the moment of inertia. That the farther away you are from that sort of center point, the more torque you have, the more center of gravity. So the more you're going to influence that balance point, that median, that mean in there, depending on how far out you are. Now I did a quick search on the internet just to show there's a few places where you almost always see people reporting the median instead of the mean, and a lot of that time is in the housing market and in incomes. In those two situations, they almost always just report the median because those distributions are very highly skewed. I did a quick search here in Google and to look at the median house price in King County. And I'm seeing from a couple different values here that currently here when we're looking at it's about 771,000 according to that real estate article. This one says it's 860,000 kinds of things. So somewhere about 80,000 roughly speaking is where that median is. And I've had students sometimes comment that, come on camera, come back to me. There I am. Am I back yet? There we are. All right. Is that it's the low-cost houses that really influence it. But that's actually not the case. If we look at housing prices, if we make just kind of a rough histogram here, you can start at over here, maybe at here's 0, and here's 100,000, and 200,000, and 300,000. Oops, got my comma in the wrong spot. And then 400,000. It's about where my house is, right in the 400,000 range. 500,000, 600,000, at least according to the assessor's office. I occasionally get people calling me asking if I'm willing to sell, and I give them a price of $4 million because, number one, if I sell my house, I got to buy a new one. So I got to find something I can afford. And with the housing prices being what they are, I need something big. And then I want to, they usually hang up on me right away as soon as I say that. But so we know that the median house is somewhere in this area, that half the houses on the market are in that area in there. But if you go look at housing that's on the market, let me do a quick jump back. Let's see how fast this goes. Oh, that's fast. If I go to, how about JohnLScott.com, and I want to look for, how about King County, Washington. What sort of houses do they have on the market? Well, let's zoom in a little bit closer here. Where'd my zoom button go? Oh. Somewhere there's a zoom in button. I guess I gotta accept these cookies. Oh, there it is. Gotta get the cookie thing out of the way. And let's go in here a little bit closer into the Seattle area here. Oh, I zoomed in. I'm zooming in on the map or on my screen? What am I zooming in on? Oh. Here. We'll do that. Let's look kind of in this area here. Somewhere around Auburn here, we'll look and see what sort of houses we have in that option. And where did my list go? Ugh. Come on. I'm not zooming in on the website. I'm zooming in on my screen, not on the website. So hang on. Okay, I think I got it working again now. So I zoomed in on some area here around Kent, Renton, a little bit of Issaquah, Mercer Island here. And it seems like, oh, there's one that's 17 million out there on Mercer Island. So where is that on our graph out there? So where is that 17 million? If I go back to my histogram that I'm constructing, turn on my camera there. And my histogram, I got 17.8 million. So there's 800,000. There is 900,000. And there is 1 million. So 1 million is right here. And the house we're looking at was 17 million. So if I go, well, there's 2 million. 3 million is going to be way over here. Whoops, you're kind of losing me here. Where's 17 million going to end up? I need to go, 17 and a half, 18 times that. That's going to be way the heck out here on my graph kind of thing. So, or even if I change my scale here, Let me maybe change my scale. So here's 0. Here's a 500,000. One too many. 500,000. There's 1 mil. Then 2 mil is going to be here. 3 mil. 4 million. 5 million. 6 million. 7 million. That's not even halfway there. And I know that half of my houses are in this area. All right. And so that $17 million house is way the heck out there. It's way a whole lot larger than anything else around it. So there's nothing over here at 0 that can really skew the data, because that's, I guess you can owe money, but the property itself still has value, right? You don't have any negative valued. There's nothing that you can go out and say, give me that property and they'll pay you to give it to you, right? You have to pay money. Even a kind of a 40-year-old single wide mobile home in a lot, it's still going to cost you a couple thousand, dollars, or maybe even, something. It's going to cost you something way down there at the very end. But there's nothing really down there. But it's the ones way up here at the top, the $17 million, the and more expensive than that. That's not the most expensive house in the Puget Sound area, but you got to get the feel there that those values way at the upper end that are really skewing that data, that are really putting the force down and pulling that average much larger. And so they almost always in real estate report the median price, where half the prices are low and half the prices, rather than the average price, because the average has these huge outliers. And the same thing happens with income. You've got I don't know what the median income is. If it's about 60,000 roughly, but then you've got Paul Allen. You got Bill Gates and Jeff Bezos and all those other guys way out there. The billionaires that are way out there that have way more income than the rest of us do. And it really strongly skews the data and really affects that outlier. So hopefully that kind of explains things a little bit, that if you see a large gap between your median and your mean, that probably means that your data is definitely skewed off to one side, whatever side the mean is. And that's what we mean when we talk about skewed data. A graph that's skewed to the right means that the mean is going to be to the right of the median, and if it's skewed to the left, that means the mean is to the left of the median, that it's pulled off to the left-hand side in there. So by comparing those two, whether it's larger or smaller, whether the mean is larger or smaller than the median will tell you whether it's skewed to the left or skewed to the right. Right? All right. Hopefully that helps understand a little bit the difference between those two. We use average, we use the mean a lot. But in some distributions, the median is much better use way to describe that distribution.